that out of there. 5 times n, 5n, 2 times 35, 70. What do I do with them, though? You said, Caitlin said cross multiply. I did. Then what do I do with the two values then? I did 5n. I got 70 when I cross multiplied the other way. What do I do with them now? Avery? Set them equal now. After you cross multiply, you set them equal and you solve for the variable. I started it off with a nice and easy one. Divide both sides by 5. What value of n will make that proportion true? 14. All right, 14. All good. All right, you and your group, cross multiply here. Next one, cross multiply. And I want to know what you end up with. Call on some people here. I want to know what you end up with. Not the final answer. Just tell me this equals this. I just got to make sure you guys can cross multiply first. I know that sounds silly in an honors class, but it's the truth. 11. Do we? One job. 2.
3x equals 2x plus 2.
There you go. Matt distributed. 3x equals 2x plus 2. And now you can solve. Okay, now you can solve. Move the 2x over. X equals positive 2. Any issues? Here's where the struggle happens now. Let's go to number 3, where the cross multiplying is not as easy as it may have been in 5th grade. First of all, is this even a proportion? Is this even a ratio, x plus 6? Yeah, it is when you put it over what? There. Oh, now we're in business. All right, so I see when I cross multiply 1 and 13, I'm going to get 13. Uh-oh. Now what happens here? X plus 6 has to get multiplied by x minus 6. Uh-oh. Uh-oh. Sorry if you missed this day last year. What's the deal here? Oh, please. I can't reteach all of it. How do we multiply those? Do you guys have like a term you used last year? What's up, Caitlin?
I think that you multiply the x with the other side and then the 6 with the other side.
Double distribute. That's what I call it. You're going to distribute twice. I don't know. Anybody's teachers use the word FOIL?
Yeah.
Hey, I'm not a big fan of that. No offense, Caitlin. All right, but I'm going to double distribute. So the first thing I'm going to distribute is the x. So I'm going to distribute the x to the other parenthesis. So I get, this is the other thing I might cry about. X times x. X times x. Yeah, thank you. It's not 2x. X squared. X times negative 6 minus. So there's distribution number 1. Second distribution, now you just distribute the positive 6 over to the other parenthesis. So you end up with plus 6x. And what number here at the end? Minus 36. Combine your like terms, and what happens in the middle here? 13 equals x squared. This is really hitting home today. All the crud you went through last year is catching up now. What happens to the 6x's and the negative 6x? Are we all right here? They're going to cancel? Or maybe you're waiting for me to pick a number, I hope? They cancel, so minus 36. Okay, where are you going from here? Solve for x. What's your next move? Solve for x. Get the 36 out of there. I get x squared equals 49. Now, I know you know what to do next because we've done Pythagorean theorem galore this year. And this is usually the last step on Pythagorean theorem. So what do I need to do on both sides? Square root both sides. So what makes this proportion true? X equals
7.
I can only give you half credit. I can only give you half credit. Anybody know why? Hi, Lauren.
Because it can also be -7.
When you take the square root of a number, you're left with the positive version and the negative version. Have we seen, watch this symbol I'm about to put up here. Plus or minus 7, we're okay. I'm going to keep using that. That means positive 7 or negative 7 for x. Head spinning yet? We're not even close to where we need to be here. Any questions right now? All right. Hopefully you like people in your group because you're going to work with them big time. Oh, and even look at the topic on top. I'm sure that brings a smile to your face, right? Yep. Big smile. Cross multiply and let me know what you end up with. Just cross multiply. Don't touch a thing after. This equals this. All right, what do you end up with after you cross multiply? 13? Anybody? All right, no. 3?
5x plus 30 equals x squared minus 2x.
Good. Any issues there? All right, now how do we solve for x? Because this isn't something, hey, look. No. That's not something we're doing here. This is different than the last problem because, see, in the last problem, all I had was x squared. Do you see in this problem, now I have an x with it. So there's no square rooting. But there is factoring. That's how I'm going to solve this, by factoring. And look, I don't feel bad at all because I've asked you to do this all year long with me. All right, we've done problems where I've asked you to factor. First thing, you can't factor unless one side equals 0. I prefer, and so should you, to make sure the x squared's positive. Don't touch it if it is. So I'm going to move over the 5x and the 30. Go ahead, move it over. And then I'll ask somebody what you're left with when you move it over. $24, Mahmoud, when you're ready. What do I have? X squared. There you go. Good, great job. So get it equal to 0. Now we can talk factoring. Now we can talk, how do I factor this? This is something we've done where we find two numbers that are going to multiply to this last number. And at the same time, it's going to add to my middle number. So multiply to negative 30, but add to negative 7. Go ahead, discuss it in your group. Claire, you go easy over there. You okay over there? You want to join somebody else? It's up to you. You don't want to roll solo, I get it. You're strong enough, though, to do it. Numbers that multiply to negative 30 but add to negative 7. What do you got for me? Oh, 4.
X squared minus 7x, negative 10 and positive 3.
Minus 10 plus 3. They add to negative 7 and they multiply to negative 30. Good job, Grip. All right there? All right, I still need values of x, though. X equals what, though? What's my final answer? That's where I go now. I set each of them equal to 0 and solve for x. So we get x equals 10, x equals -3. Two answers. Could be either one, what makes that proportion true. Questions? All right, because we're going to work on this tomorrow, we can take our time now. Work on number 2 in your group right now. I'll come around, help you out individually as a group if you need it. Try out number 2 as a group right now. Congratulations, and I think we just got to the mark. Yeah, that's not what I wanted. When you set it equal to 0, x squared plus x minus 12. We're good there. Now I look to factor. X plus 4 and x minus 3. Two numbers that multiply to -12 but add to 4 or add to 1. We're all good. Now set each of them equal to 0. X equals -4. X equals +3. All good? Questions? All right, go ahead. You and your group. Number 3. Number 3. Let's get better at this. Number 3. Getting a little better now? Getting a little better, a little more confidence, hopefully. Two numbers that multiply to -20, but add to 1. Recording. We got what? +5 and -4. So we have x equals -5 as an answer and x equals 4 as an answer. All good? And I see some of you mathletes there trying to go number 4, and you're like, oh boy, what's going on here, huh? What the heck is this? All right, good. All right, everyone's all right. Now, we are in what course? Honors, right? So it's just not like, all right, every time you got a factor, this is the way you're going to do it. Because I don't know if you remember last year, there's multiple ways to factor it. And in honors class, I don't feel comfortable just going, all right, it's going to be always this way. I got to show you something else, another way to factor. Like, what if this way can't be done? How else can I do it? If you haven't done so already, go ahead, cross multiply. On number 4, go ahead, cross multiply if you haven't done so already. I don't feel comfortable just saying, this is the only way we're going to factor. When you cross multiply, what do we end up with? Just tell me what's equal to what. I don't need to know anything else. 19?
3x squared equals 30x.
Good job. Equals 30x. Perfect. All right. Still, no square rooting here because I got the x here with the x squared. So no square rooting like I did in problem 3. Or problem 3 from the previous page. Still got to set it equal to 0. That rule never changes. I don't care what method of factoring you're using, you have to set it equal to 0. So let's move over the 30x. Ready? 3x squared minus 30x equals 0. The method we've been using for the last 3 problems only works on a 3-term polynomial. This has how many terms? Okay, so that's multiply to this and add to this will not work because this has 2 terms. I need 3 to do that method. So we're going to do a method. I call it GCF. I don't know what your teachers may have called it last year. Take out something they both have in common, both terms. Does everyone see they have a 3 and a 30? You got a number that goes into both? 3 and 30, what number goes into both? 3. So I'm going to take out, divide out 3. And they also have what variable? X. So not only am I going to divide out a 3, I'm also going to divide out a 3x. Because that's what's common in both terms. Now, I'm going to tell you what's left in a set of parentheses. After I divide out 3x from each term, I'm going to tell you what's left. So 3x squared, and I just took out the 3 and the x. What's left? What's still left over? There's something left over. An x, right? Because I had 2 of them to begin with, and I just took out 1. So there's an x left. And what's left when I take a 3x from 30x? 3 in the 30. 10. Minus 10. Any x left? Any x left to put in? No, I already took it out. It's right here. So that is what that is factored using what's called the GCF method. I take out something in common. Still equal to 0. And just like we did with your parentheses, we're going to set each of them equal to 0 and solve for x. So I'm going to take 3x, set it equal to 0. And I'm going to take x minus 10 and set it equal to 0. So go ahead, solve for x. X equals 0, right? Divide both sides by 3. There's one answer, 0. And what do I get over here? X equals 10. Both my answers there. So a different method. Okay, different method. Now, quick question for you guys since you're in honors. Why Why did it not make sense for me to do the GCF method, say, on this problem here? Anybody? Why would it doesn't make sense to do GCF here? Is there anything they have in common that I could take out? All three of them, not just 2 out of the 3, all 3. Other than the number 1, is there anything I could have taken out? No. That's why I don't use GCF there. There's nothing to take out. I only want to use GCF when there's something I could take out of all the terms. Questions with you guys? All right. I'm going to end it today on just a quick review on how to simplify radicals. And this will lead into the rest of the notes tomorrow. Have we broken down radicals this year? Oh, you're darn right we have, right? I never like decimals. I want that thing simplified. Before we do, let's just get a quick reminder, refresh, because you're going to need a perfect square that goes into all these radicals. So let's review first what's considered a perfect square. First, anybody want to throw a perfect number that's considered a perfect square out at me?
9.
9? Yep. Others? 4? Okay, I'll start with 4. Then I'll write 9. Any others?
16.
16. All right, I'm just going to stop there. I'm not asking you to memorize these. Do you know how we got 4, 9, 16? What's 2 squared? 3 squared. 4 squared. Just take any darn number, square it, and you know what you get? A perfect square. All right, so that's, you don't need to memorize them. Just take a number, square it, and it's a perfect square. So let's go to the square root of 72. Simplify that a little bit more for me. Square root of 72. You guys got you break it down into 2 radicals. Underneath the first one, not just any perfect square, the biggest one. Because I know a lot of you are going to find out that 9 goes into 72 evenly, which it does. But I need the biggest one to make sure it's simplified all the way. So there's something, keep checking. Even if you find one right away, keep checking because there might be one bigger. Got to go in evenly. Evenly. Just not the biggest one, evenly. And other than 9, what's the biggest one? 36. Correct. 36. So I put a 36 under the first one. And what do you got to multiply 36 by to get 72? 2. Square root of 36? 6. And then the radical 2 comes along for the ride. There it is. 6 radical 2. Radical 32. Here you go. Let's break it down. Some of you are going to get happy. Oh, 4 does. 4 does. Got to keep checking because 4 might not be the biggest one. And if I'm saying that, it probably isn't. Biggest one? 1, 6. 16. 16 times 2. So square root of 32 broken down is going to be 4 square root of 2. All good? Let me up it a little bit now. Simplify square root of 48 over 2. Oh, geez. Well, that's going to be square root of 24 because 48 divided by 2 is 24. That's not how this works. All right, that's not how it works. 48 is under a radical, 2 is not. They cannot be divided. One's underneath the radical, the other is not. Plus, anyway, is this number really 48? No. You know what that number is? There it is. That's what that number is. It's not 48, so I can't divide it by 2. All right, that's what that number actually is, the square root of 48. But I am still going to expect you to, if this thing goes off. All right, good. I'm still going to expect you to break it down. You may not be able to divide it, but you can simplify it. Oh, 4 goes into 48. 4 goes in. Not biggest. Now, I would like you, I'm going to tell you what happened in my other period today and tell me why it's incorrect. Somebody thought, they raised their hand and said, oh, 24. 24 times 2. What's the problem with 24? 24 times 2, 48. What's the problem, though? Thank you. It's got to be a perfect square. 24 is not. But what is the biggest perfect square? It's not 4, but 16 times 3 over 2. Let's keep grinding. 4 square root of 3 over 2. And I gave you this problem because we're not done. We're not done. We could still simplify. What do you think? We could still keep going. That's not simplified enough. What do you think there, Avery?
Maybe you can divide
Maybe.
4 by 2.
Maybe. 4 over 2. Yeah, why not? Is the 4 underneath the radical? Is it 2? No, let's do it. 2 radical 3. There it is, simplified. Square root of 150 over 5. Have fun in your groups. Let's go. Go ahead.
Radical 6 is 1.4. 169. That's about 150. So that's
Okay.
150. This was a new perfect square that went into it, which was 25 times 6 over 5. So radical 150 simplified to 5 radical 6 over 5. Gave it to you for a reason. Keep going. What do you think can happen here? 5s. They're both not underneath the radical. You can divide them. Or cancel them out, whatever you prefer. And what's my final answer? Radical 6. All right. Tomorrow, here's how we're going to start class. What if I get one of these and I can't factor anymore? I can't. It's impossible. Like, I'm thinking the numbers that do add, multiply to this and add to this, and it's not happening. There's no way I'm going to find numbers that do it. Quadratic formula. Okay? So here's the plan for tomorrow. You can take the night off. We'll finish the notes, and then you can start the assignment tomorrow in your groups. Whatever you don't finish, it'll be for homework. All right? Good deal? Fellas, have a good night. It's getting real.